So now we're going to look at how to create SSI down counters that are synchronous counters, all connected to the same clock. So we're going to start where we started before, which is here. We're going to create a 3-bit down counter, and it is a synchronized counter. So what that means is my clocks are all connected for the same input. So we're going to start with the clock input. So our clock input might look something like this. And again, it's attached to each flip-flop so that they get clocked at the exact same time. So we're going to do the same thing we did before, and our first flip-flop will be our least significant bit, and then the middle, and then the most significant bit. So we'll start with Q0. Okay, so again on Q0, this time I'm counting down. So instead of looking at going from 0, we're going to start at 1. So I'm going to go from 1, and it is a negative edge trigger. So at that negative edge, I'm going to go down to 0. And then at the next negative edge, it'll be up to 1, then to 0, 1, 0, 1. So 0, 1, 0, 1, 0, 1. Because again, I'm counting down. So I've got my 1, 2, 3, 4, 5, 6, 7. I'll need another one here. 8. So that is going to be my smallest bit there. Okay, so at each negative trigger of the clock, I'm getting a change in my Q0. So all I need for it to do is toggle at each falling edge. And that's exactly what a flip-flop is going to do anyway. But of course, in order to make the JK flip-flop toggle, it needs to be connected to power. Again, J and K, when I have a 1 and a 1, that's when I get the toggle. So that's what I'm doing by connecting my J and my K to 5 volts. Okay, so moving on to the next one, I want to do Q1. So for Q1, it's going to also start at 1 because again I'm counting down. So I'm going to have 1, 1, 0, 0, 1, 1, 0, 0, etc. So it should look something like this. Okay, so again, we got to look at when do I want that Q1 to change. It is going to change on the negative clock, the falling edge, but the problem is I don't want it to change on every falling edge. At this falling edge, there was no change. So how do I tell my circuit only change when I've already done one toggle here? Well, before we were looking at Q0, and Q0 was a 1. Here, I want that toggle to happen when Q0 is 0. So Q0 is at 0, then I get my falling edge. That's when I want this to change. So the clock signal and when Q0 is equal to 0. That's when I want it to toggle. So here, when I have a falling edge right here, but my Q0 is at 1, I'll get no change here. So in order to do that, instead of connecting my J and K to power, I want it connected to the output of this flip-flop that indicates when Q is 0. So I can do that one of two ways. I can connect it to Q0 with an inverter, but an easier way to do that and a more efficient way to do that is to connect it to Q0. So when Q0 is a 1, Q0 is a 0, that's when I want my Q1 to trigger on the falling edge of that clock. Okay, going on to Q2. Q2 is going to be half the frequency again, and we'll be starting at 1 because we are counting down. So here we're at a 1, and then we change to a 0. So looking at this again, it is going to trigger on a falling edge of the clock, but I only want it to do that when both Q0 and Q1 are at a 0. So when I connect up my last flip-flop, I'm going to want a AND gate here that indicates that Q0 is at 0 and that Q1 Q1 is also at a 0. So I get those two inputs at 0, and the clock input will give me the Q2 output. And that's how I create a down counter. Again, if I want to create a 4-bit down counter, all I would have to do is add that additional flip-flop here. Again, we'd be doing a JK and a clock with my Q3. This would be my 4th bit. My clock would be connected to the same clock as the others, but this time I need to know that J and K are both connected to Q0 when it's 0, to Q0 or Q1 when it is 0, and to Q2 when it is 0. When all three of those are true and I get my clock input, that's when I would trigger a change in my Q3 output. And again, we do that because we know that when J and K are 0, there's no change. So that's what keeps my Q2 output and my Q3 output from changing prior to this point. So I have a falling edge, but nothing happens. I have a falling edge, but nothing happens. And I can't select just Q0 because right here I would have a change made because I'd have Q0 at 0. So both of these must be 0 in order to trigger the change. Okay, so following this video on Canvas, you're going to see an activity where you're going to get to build a down counter in Multisim, and then you'll upload it here as well.